So in this video, we're going to talk about what correlation is. And correlation itself is just the measure of linear strength and direction between what we call bivariate data. And when we refer to this stuff as bivariate data, the word bi means two. So bivariate data means you have two variables. And what you're trying to do is develop a relationship or some kind of association between those two variables. And in particular, correlation only works with quantitative variables. And remember, when we say quantitative variables, we're talking about numbers. So if we're going to develop this association, the variables have to be numbers to do this. So you need to check that when you look at these type of things. And when we talk about the showing this linear strength and direction here, the linear strength and the direction that we have here, when we talk about these two things, we're going to show it through what we call a scatter plot. Right? And on your scatter plot, you have two variables you're going to focus on. You have your x variable, which is going to be called your explanatory variable. And you put it on your x-axis. And then you have your y variable, which we call our y variable is called our response variable. And that is on the y-axis. And you can think of this as your explanatory. It explains something. So when you explain, you're the independent variable. So your explanatory is your independent variable. And what happens is your response is going to move based on the explanation. So this is going to be your dependent variable. And what you're looking for now is you're looking to read x and y together. And when you read it, now what's going to happen is it's called a scatter plot because what you're trying to do is you're trying to develop a line, some kind of linear relationship between these. Except that relationship normally is not going to be a perfect line. You're going to scatter around the line. And so when you get that, you can talk about your direction and your strength. And the direction, it just means what is the actual slope of the line. The direction is what is the slope of the line. And remember, a line has three different slopes. So basically, when you set up your scatter plot, you can have what's called positive direction or positive slope. And that just means that the line moves in a positive direction like this. And what this says is that as the explanatory, or as x increases, the y variable is also increasing, or the response is increasing. You can also have negative correlation. And in negative correlation, here's x and here's y. This says that now as x increases, x will always increase, by the way. As x increases, now the y variable is decreasing. So they have what we call an inverse relationship. And again, it's just me looking at the slope of the line. All I'm doing is focusing on the slope of this line, right? And so the last type of thing that's going to happen is if x and y increase together, or as x increases and you can't tell exactly what y is doing, that means that linear relationship is doing nothing for you. And that's because the two variables are basically independent. And we say that means that there is zero correlation. So the last type of correlation is what we call zero correlation. It looks something like this. When you have a whole lot of scatter, you can't really tell what's going on. And so this says as x increases, there is no linear relationship. We care about the linear relationship. And remember, the word linear just means line. So there's no kind of line that you can form out of it. No linear relationship between x and y. Right? And the reason we like lines is because lines continue to move in one direction based on their slope. They always move in the same direction based on their slope. So if we can get a slope, we can actually try to predict based off that line value. And the more of a line it is, the more alignment it is, the better the line it is, the stronger or close to the line it is, the easier it is to make those predictions. And that value that we're going to talk about now is what we call our strength. And so when we talk about our strength, we're going to talk about this thing that we call the correlation coefficient. So we're talking about what we call the correlation coefficient. And the correlation coefficient actually gives you the strength and the direction of the line. But the scatter plot gives you direction. But you can get the strength now by looking at a value that we call the correlation coefficient, or what we call R. And R tells you how close to a line something is. And so your R values range from, R is always in between -1 and +1. And so we say R is always in between -1 and +1. So if it is -1, we call that perfect perfect negative correlation. And it is a perfect negative line. If this is positive one, we call it perfect positive correlation. It's perfect positive. And that's R equals 1. And now, because it's a scatter plot, though, we know that scatter plots can range around the line. They scatter around the line. And because they scatter around the line, what happens now is our R value can actually go between -1 and 1. And so when we talk about the strength, we're going to develop strength measures for R. And so R can either be strong, it can be moderate, or it can be weak. And based off of that, you're looking at your R value, the magnitude of R, which means you don't care about the sign right now because we know our sign is the direction. So if R is negative, that means you have a negative slope. And if R is positive, it means you have a positive slope. So when we talk about strong, we're looking at just the magnitude of the value of R. And we say that R is strong if the values are generally between 0.7 and 1. We generally call that a strong relationship. So if R is in between 0.7 and 1, we call it strong. It's called moderate generally if it's between, we say about 0.3 up to 0.7. And then it's weak generally if it's less than 0.3 to 0, or to 0, where we're not going to include 0 because that means it's zero correlation. That means zero correlation is actually equal to 0. So these are general guidelines. They're not hard set, and you may see them stated differently in other places, but we can generally say if your R value falls in between these values like this, you have strong, moderate, and weak. And now that we have the basis of this out the way, we're going to talk about how do we use the correlation to talk about things. So I'll do that in the next video.